Okay, today we can discuss about bending stresses on this I section. This has two flanges of length 200 mm. Total height of this I section is 400 mm. The flange depth is 20 mm. Web length is 10 mm. This I section carries a uniformly distributed load of 40 kN per meter run on a span of 10 meter. Okay, so here we can note, I think, cross section, breadth and depth, length. Okay, it will be like this. Okay, it will be like this. This is length, this is breadth, this is depth. Length, breadth, depth, or length with depth, anything. Depth or thickness, anything. The span is 10 meter, breadth 200 mm, depth is 20 mm each. This is flange. This is web. One web, two flanges. I section has one web, two flanges. What about its symmetricity? Can you tell me? See the diagram. Can you tell me about the symmetricity of this I section? Symmetric section or unsymmetrical section or anti-symmetric section? See the diagram. Any volunteer? Can you unmute? Symmetrical section or unsymmetrical section? You can post your answer. This is symmetrical section. Symmetric about X and Y axis. Okay, if you cut into to about this neutral axis, you can see the same image in the upper and lower portion about neutral axis. Similarly, if you cut this section about this vertical reference axis, you can see same image in the front and back section to this reference axis. So this is known as symmetric section about both x and y axis. Symmetric section means x bar value. Symmetric section, symmetric about x axis means what about y bar value? Y bar value, any volunteer? Y bar is Y bar is total breadth by 2. Symmetric about y axis means symmetric about x axis means y bar is equal to b by 2. Symmetric about y axis means x bar is equal to y bar is equal to total depth by 2. Symmetric about y axis means x bar is equal to total width by 2. Okay. Here Width is 200 mm. Width is 200 mm. Depth is 400 mm. If it is symmetric about x-axis, you can cut the section into two equal halves. About x-axis means y bar value is total depth by 2. If it is symmetric about y-axis, if you can able to cut the section into two equal halves, about y-axis means x bar is equal to total width by 2. We need to remember these conditions. This is for symmetric about x-axis. This is for symmetric about y-axis. Okay, we know some basic understanding. Unsymmetrical section means okay, this is not symmetric about x-axis and the y-axis. This is unsymmetric section. Unsymmetric section. We can't cut into two equal halves about this axis, about x-axis and y-axis. So this is known as unsymmetric section. This is anti-symmetric section. Anti-symmetric. Okay, this B is equal to equal with only, okay, you can consider. Okay, this breadth is equal to this side breadth, flange depth is also same. Okay, so this is anti-symmetric. Okay, same with the depth, but not in the same direction. One side is in the direction opposite to the existing flange. This flange is in the opposite direction to this flange. This is anti-symmetric. Anti-symmetric. Okay, but in our case, we are considering symmetric eye section. Flange, width, height are same. So this is symmetric section. Please note the values. Span is 10 meter. UDL value 10 kilonewton per meter. 10 kilonewton per meter. I request everyone to join through Google Classroom. Okay, we can solve this problem now. This is eye section. 20 mm. Flange depth 200 mm. Width we know bending stress sigma b is by y is equal to m by I. Sigma b is equal to sigma b by y is equal to m by I. Here uniformly distributed load magnitude is 40 kilonewton per meter. So we can write it as 40 into 10 power 3 Newton per meter. Meter can be written as 10 power 3 mm Newton per mm. So 10 power 3, if it goes up, 10 power minus 3. 10 power 3 into 10 power minus 3 value, 1. So 40 Newton per mm. This is W value. So here we need to find the maximum bending stress due to bending. Can you tell me y equation? Y is equal to, see the diagram, y is equal to, total depth by 2. Total depth by 2. Total depth is 400. So 400 mm by 2. 200 mm. Okay, 200 mm. So we found y value, that is 200 mm. Next we need to find the moment and the moment of inertia. So we can try moment of inertia. So we know that sigma b by y is equal to m by I. Here y means total depth by 2. Total depth is 400 mm. So 400 by 2, 200 mm. Okay, next moment of inertia. The moment of inertia formula. Can you tell me moment of inertia? This is symmetric about both x and y axis. What about moment of inertia? Moment of inertia. Moment of inertia. I is equal to 3 rectangles are there. So I1 plus I2 plus I3. Or you can write, okay, you can consider it as rectangle minus this portion. Total rectangle width is 200, depth is 400. So we can write total depth b d cube 400 mm the whole cube by 12 minus, you need to cut this 10 mm from 200. So 190 is the width. You can subtract only this portion. And the height 400, we can cut 20, 20. So 2 into 20, 40. 190 into 360, the whole cube by 12. Okay, you can use this method also. You can use anything. Here I1 is equal to B1 D cube by 12. Here B2 D2 cube by 12. Here B3 D3 cube by 12. You can use this method or you can use this method. You can subtract this web width and the flange height from total thickness and width. Okay, see here. Okay, this is total rectangle 200, 400. Okay, we need to subtract this portion. Okay, we need to subtract this portion. This hatched lines shows the section to be cut. So we need to cut this 10 mm From total width, we need to cut 20 mm, 20 mm. Total 40 mm. Okay, 40 mm. So now width becomes 200 minus 10 for 190. Height becomes 400 minus 20 plus 20, 40. 360. Okay, can you tell me your I value now? I value. Please do the calculation. Please tell me your I value. Surya Kumari, your answer. I value. This is symmetric about x and y axis. So we can use this method. We can better cut web thickness and the flange height from total rectangle. Okay, I value. Surya Kumari, your answer. Your answer, Rufus. Your answer. Can you tell me your answer, Sharon? You can tell your answer. If you have any doubt also, please ask. Okay, very simple. This is symmetric about x and y axis. So x bar means total depth by 2. Y bar means total width by 2. Here we can consider entire rectangle from which we can subtract web width and flange height. That's it. In this way, we can have two sets of B and D. 200, 400 and 190, 360 respectively. Your answer, I value. I value. I value. Surya Kumari, your answer, Surya Kumari.
Yes, ma'am.
327.98 into 10 power and 10 power 6
6, ma'am.
mm power 4. This is I value. Now we noted I value, Y value. Only moment is to be found. Here condition is there. Simply supported beam of UDL. UDL 40 kilonewton per meter or 40 into 10 power 3 into 10 Newton per meter. Meter means 10 power 3 mm. If it goes up, 10 power minus 3 Newton per mm. Okay. Plus 3 minus 3 cancel. 40 Newton per mm. Span is 10 meter. We can name. This is A. This is B. Okay, we can name the ends A, B. UDL magnitude is 40 kilonewton per meter. Total span 10 meter. So 40 into 10 power 3. 1 meter means 10 power 3 mm. 10 power 3, if it goes to the numerator, it will be 10 power minus 3 Newton per millimeter. Okay. This is UDL over the entire span, the maximum bending moment at center of the span or at the mid span. Okay, mid span is C. C distance between C and section B is 5 meter. From A also 5 meter. A to C 5 meter, C to B 5 meter. Okay. If it is simply supported beam, first we need to find reactions RA and RB. Okay, we know moment about A is equal to 0. The moment about A. Moment about A. Equation. Moment about A is equal to 0. Moment about A. You can start from right end. So RB. Upward force into distance. Force into distance 10 meter. Next, UDL means 40 over the entire span. So 40 into 10, half distance. So 10 by 2 is equal to 0. Okay, what about RB value? RB value. RB is equal to RB into 10 is equal to 40 into 10 into 10 by 2. Okay, we can cancel 10. RB value is 2 into 10, 20. 20 into 10, 200. RB value is 200 kilonewton. Can you able to understand? Can you able to understand? Please say yes or no. Okay. Moment about A is equal to 0, we need to start from forces acting at the right end. At end B, we can see reaction force RB. RB is actually an upward force. So plus RB into distance between RB and section A is 10. RB into 10. UDL is downward force. So we can give negative sign. So minus 40 into distance 10. For UDL moment, we can consider half distance. So 10 by 2 is equal to 0. Now RB is equal to 200 kilonewton. RA plus RB is equal to UDL value 40 into 10. Okay, RA plus RB minus 400 is equal to 0, or we can write RA plus RB, upward force, upward reaction forces RA plus RB is equal to 40 into 10. UDL 40 kilonewton per meter into distance. Here we can add 10 power 3 also. We can replace the kilo by 10 power 3. RB value is 200 kilonewton into 10 power 3 is equal to 400 into 10 power 3. So RA is equal to 400 minus 200. 200 into 10 power 3 Newton. Okay, next. We know now RA value. We know now RB value. So moment about C is equal to RB into 5 plus RB into 5 minus 40 kilonewton. Okay, we can consider UDL from B to C. We can consider only right portion of section C. So 40 into 5 into 5 by 2 minus 40 into 5 into 5 by 2. RB value 200 into 10 power 3 into 5 minus UDL value, UDL also into 10 power 3. So 2, 40, 20. 20 into 5, 100. 100 into 5, 500 into 10 power 3. Okay, 2 into 5, 10. 1000 into 10 power 3 minus 500 into 10 power 3. Answer 500 into 10 power 3 Newton meter, I guess. Yes, Newton meter. Newton meter. In terms of millimeter, 500 into 10 power 3. 1 meter means 10 power 3 mm. Newton mm. 500 into 10 power 6 Newton mm. MC. Sigma B is equal to m value, m by I into y. M max or m into y max, say anything. M value 500 into 10 power 6 by I value 327.98 into 10 power 6 into 10 power 6. Y value 200. 4. Okay. If you substitute everything, you will get 304.9 into 10 power 304.9 Newton per mm square. Did you get the same answer? Three not 4.9 Newton per mm square. A sigma B value. Yeah, did you get the same answer? Can you able to follow me? A very simple problem. This is symmetric about both x and y axis. In bending stress topic, we need to worry about y bar. Okay, y bar. If it is symmetric section about both axes, moment of inertia can be considered the entire section minus width, thickness and flange height. Using these two sets of B and D, we can easily predict the moment of inertia. Here y means total depth by 2. Moment, bending moment can be found as U-shape. Beam approach, shear force and bending moment approach. Here we can ignore shear force, but we need to find two reaction forces for the simply supported beam. We know one reaction at every support. So RA plus RB is equal to external load. If it is UDL into length over which UDL is distributed. Next, we can find moment about section A, that is equal to 0. We are using condition of equilibrium. When we move from right end reaction RB into distance between section B and section A minus UDL into total distance into total distance by 2. This will give you moment value. Okay, next we can substitute all these values in bending stress equation. Okay, bending stress sigma max is equal to 304.9 Newton per mm square or maximum bending stress is equal to 13.581 into 10 power 6, sorry, 304.9 into 10 power 6 Newton per meter square. Okay, first question over. Do you have any doubt? Okay, next question. This is unsymmetrical section. Unsymmetrical section about x-axis and also about x-axis. About y-axis, this is symmetric only. If you cut it into two equal halves about the center line of this I section, this side length height will be same as length depth in the opposite side. So this is symmetric about y-axis but unsymmetric about x-axis. Here the cast iron bracket subject to bending has the cross section of phi form with unequal flanges. Flange length not same. Top flange width is 200 mm. Bottom flange width is 130 mm. Top flange thickness or depth is 50 mm. Bottom flange depth or thickness is also 50 mm. Okay. We need to find the position of the neutral axis. Neutral axis is the axis where we can't see neither elongation nor compression. So we need to find the position of neutral axis and also moment of inertia of the section about the neutral axis. If the maximum bending moment on the section is 40 meganewton millimeter, determine maximum bending stress. What is the nature? Okay, please listen. If sigma b is negative value, this is compressive stress. If it is positive value, bending stress is tensile. Tensile. Okay, please note. Negative stress means compressive stress. Positive stress means tensile stress. So here we need to locate the neutral axis and also moment of inertia about the neutral axis. Bending moment. Usually they won't give bending moment, but here bending moment is given. That is 40 meganewton millimeter. So 40 into mega means 10 power 6 Newton millimeter. Maximum bending moment 40 into 10 power 6 Newton millimeter. Okay, we need to find bending stress. sigma b by y is equal to m by I. Okay, we know bending moment. Y value. Can you tell me y value? Y value. Y value. See the diagram, 200 plus 50 plus 50. So y value. This is unsymmetric section. So y value. How we can find y value? Very simple question. You can post your answer. Y value. Here y value means y bar. Y value means y bar. Y bar is equal to sigma ay by sigma a. Please note all the equations. Y is equal to y bar. Sigma ay by sigma a. Y bar value. Brittany, y bar value, Brittany. Only Brittany is listening always my class. Only she asking questions. Brittany, your answer, Brittany. Y bar value.
Ma'am, I'm solving, ma'am.
Sorry, okay. Please tell me the equation. Sigma ay, can you uh, apply it for this unequal I section?
A1 into y plus A2 into y2 plus A3 into y3 divided by summation of A.
Very good. So y bar is equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Okay, this is our I section. Okay, we can consider three rectangles. I am numbering it from bottom to top. Okay, this is 130 mm, 50 mm, 50 mm, this is 200 mm, this is 50 mm. Okay, so A1 means 130 into 50. X1 means half distance, 130 by 2. Y1 means half depth, 50 by 2. A1 value, Vishal, A1 value, 130 into 5, 13 into 5, 650, 6500 mm square. X1 value 65 mm. Y1 value 25 mm over for rectangle 1. Okay, next rectangle 2. Rectangle 2. For rectangle 2, A2 is equal to width is 50, height is 200. So 10,000 mm square. X2 value 50 by 2, 25 mm. Y2 value Y2 value 200 by 2, 100 mm. Okay, Y2 value. Okay, Y2 value. Okay, we need to draw reference axis always from bottom axis. Okay, we know reference axis always from bottom axis and vertical axis always from left axis. So y2 means okay, y2 means 200 by 200, correct. We need to consider the previous section depth 50 plus 200 by 2. So 50 plus 100, 150. Okay, you can ignore now x2 value. X2 is not needed. We want only y bar. So we can ignore x2. X2, if you want 50 by 2, 25. And the distance from reference axis to this distance. This is 130. 130 minus 50, 80. So 40, 40. This is 40. This is also 40. So 40 plus 25. X2 will be 40 plus 50 by 2. 40 plus 25, 65 mm. X2 value 40 plus 50 by 2, 65 mm. For this calculation, X2 and X1 are not needed. So you can skip. Okay, you can consider only. Okay, you can ignore X1, Y1, sorry, X1, X2. Y2 is equal to 50. From bottom axis, we need to find. For this concerned section, height of this section 2 by 2, and we need to consider previous depth, 50 mm. From this bottom line only we are measuring. So y2 is equal to 150 mm. Y1 is equal to 25 mm. Can you able to follow me? Please say yes or no. Can you able to follow me? Sheena, can you able to follow me?
Yes, ma'am.
Okay, next A3, Y3. A3 value. Any volunteer A3 value? Third rectangle. Okay, shall I take next slide? A third rectangle. Rectangle 3. A3 is equal to A3 is equal to 200 into 50. 10,000 mm square. Okay, Y3 is equal to 50 plus 200 and half depth. 50 by 2. 250 plus 25, 275 mm. So Y bar is equal to sigma AY by sigma A. Can you substitute everything? Can you tell me your answer? Sigma AY by sigma A. Sigma AY by sigma A. Answer. Sashmita, your answer.
Ma'am, I'm calculating, ma'am.
Who calculated now? Divyashri, your answer. Sigma AY by sigma A. Answer. 166.5 mm. Okay, next we want IYY. IYY is equal to IYY1, IYY2 plus IYY3. IYY1 equation is B1 cube by 12 plus A1. Okay, Y1 value 25. Okay, IYY is equal to IY1 plus IYY2 plus IYY3. Okay, IYY1 formula B1 D1 cube by 12 plus A1. Y1 is 25 mm. Y bar value is this is not symmetric about x-axis. So we need to use parallel axis theorem. B1 D1 cube by 12. If it is passing through centroid, we can tell B1 D1 cube by 12. But here this is not passing through. Section 1 center is not passing through centroid. So we can write B1 D1 cube by 12 plus A1 of bigger value is y bar minus y1 the whole square. Okay, for IYY2 B2 D2 cube by 12 plus A2 y bar minus y2 the whole square. Okay, for IYY3 B3 D3 cube by 12 plus A3 of y3 is bigger value, y3 minus y bar the whole square. Okay, if you substitute everything, you will get IYY is equal to 287.358 into 10. Okay. Mm power 4. This will be your IYY value. In this question, bending moment is given. Maximum bending moment is given. Only we need to find the stress. So here y means y bar. We know the equation. Sigma B max by y bar is equal to m by I. M value is 40 into 10 power 6. Y bar value is 166.5 mm. I value is 287.358. Okay. Answer. Can you substitute everything? Tell me your sigma B max answer. Sigma B max answer. Sigma B max answer. Sharon, sigma B max answer. Sigma B max answer. Sigma B max is equal to 23.177 Newton per mm square or 23.177 into 10 power 6 Newton per meter square. Okay, please note this value. 23.177 Newton per mm square or 23.177 into 10 power 6 Newton per meter square. Okay, I will post this recording problem, everything. Please listen to me. Very simple topic. Here we can see unequal flanges, top and bottom flange of this I section or I form not same. So we need to find y bar from individual rectangles A1, A2, A3, Y1, Y2 and Y3 values. Y bar is equal to sigma AY by sigma A. Here y value should be measured always from bottom edge of bottom rectangle. For first section alone, depth by 2 will give us y1 value. From next section, from subsequent section, we need to add previous section depth plus half depth of the concerned section. In this way, we noted A1 value, Y1 value, A2 value, Y2 value, A3 value, Y3 value. We noted 6 values. Okay. So sigma AY means A1 Y1 plus A2 Y2 plus A3 Y3 divided by sigma A means A1 plus A2 plus A3. We got Y bar value. Okay, next bending moment value is given. I can be calculated from individual moment of inertia about y axis. Here we noted unsymmetricity. So we need to use parallel axis theorem. B dq by 12 plus a y bar minus y the whole square. Here centroid of the section not passing through centroid of the entire section. So first section means B1 D1 A1 Y1. Y bar value is common to all these rectangles. Next IYU 2 IYY2 B2 D2 cube by 12 plus A2 of Y bar minus Y2 the whole square. IYY3 B3 D3 cube by 12 plus A3 of Y3 minus Y bar the whole square. You can write bigger one first and the lower one. Anyhow, you will square it. So no change in the answer. But if you can put the bigger value first. Then you can subtract lower value from the bigger one. So we got I value. We know moment value. Here y means y bar for this unsymmetrical section. So sigma B max by y bar is equal to sigma B. We can substitute values of other variables. It will give us 23.177 Newton per mm square. 1 millimeter is equal to 10 power minus 3. Mm square means 10 power minus 6 meter square. If it goes up 10 to the power 6 Newton per meter square. Okay. I solved this question. I will post in GCR. You can attend next class. Okay, thank you. Okay, please solve all the problems within these 5 questions. You can expect one question, one pattern.
Oi.